For example, when we talk about the famous people like sports people like Messi or Ronaldo or movie stars like Tom Cruise, so all these people have a lot of followers. Say a famous person has like 10 million followers. So using this push based approach, whenever a famous person creates a new post, what we are doing is like pushing it for 10 million people. So we are creating a lot of requests by our own. What it may do is like bombard our own system, so our own system can go down, because what we are doing is like we are sending so many requests from ourselves. If you're planning to give interviews soon, this video is for you. Hi, my name is Mohit Chabda, ex-Salesforce, ex-Walmart. And in today's video, I will tell you what were the questions that were asked to me in this mock interview. What was my answer to each of those questions and what was the feedback that I received on my answers. So the question that I was asked in my mock interview was, design a photo sharing application like Instagram. So these were the functional requirements that were given in the question, because functional requirements will tell like what is the system that I need to design. So here are the functional requirements. Number one, user should be able to create posts featuring photos, videos, and a simple caption. So as you know, Instagram gained popularity as a photo sharing application where user can post images and videos. So this is the number one requirement of our feature. Number two, user should be able to follow other users. So in Facebook, this funda of follow, it was bi-directional, that if A tries to make friend with B, B also is now the friend of A. But in Instagram, it can be one way. So A can follow B, but it's the choice of B to follow back to A or not. So it can be one directional. And the third functional requirement is that user should be able to see a chronological feed of posts from the users they follow. So basically you see the user feed whenever you open Instagram. It mostly shows you the posts from the people you follow. So I had to keep these major things in mind while designing my system. Now let me share with you what were the questions that were asked to me one by one, and alongside that I'll share my answer and the feedback that I received. So the first question that was asked to me was, what are the non-functional requirements of the system? So the interviewer already told me the functional requirements, and based on these functional requirements, now I have to tell what are the non-functional requirements of this system. Now I will recommend you that you pause the video here and you write down what according to you are the non-functional requirements, because now I'm going to show you what was my answer, and after that I'll tell you the feedback. So if you write down your answer, it will really help you. Although in system design questions are open-ended and your approach can be different from mine, but still when I'll show you the feedback, you might be able to relate to that and you could see some of the good practices that you should follow while giving the actual interview. Okay, so this is the answer that I gave to the above question. Number one I mentioned was high availability, which means that the system should be available all the time. You know, Instagram like application is used worldwide, right? So there are different time zones and people also use this application all the times, even during the midnights or the daytime. So the application should be always available. You might have seen like whenever Instagram is down even for few minutes, then it becomes a big news. So when we are trying to build a system like Instagram, we need to make sure that it is highly available. Okay, the second point I mentioned was latency, and I also gave some numbers like the latency should be less than 150 milliseconds, because you know when you open Instagram and if it is taking a lot of time to load, you would just close the application, right? So if we want that user really like our experience, the latency should be minimal. And the third part is reliable. So if a user has posted something, it should remain there. Say for example, you posted an image, right? You should be able to check that image later. So these were the three non-functional requirements that I gave as an answer to this question. Now let's see what was the feedback that I received. Okay, in the feedback, first of all, I was told what I did well. So the first thing that I did well was like identified availability as the core or the essential non-functional requirements because it is essential for Instagram. Number two, I use the numbers and mention what would be the number, like latency should be lesser than 150 milliseconds. So that is a good part, because otherwise if you just say low latency, it might seem very generic. Another good part of my answer is that I tried to keep it specific to Instagram. So whatever the question is asked, you need to make sure you are telling as per the question only. So don't keep it too generic, make it specific to the current system. Okay, so this was a good part of my answer, but I also received some improvement area. So one was like, although I mentioned the latency, but when we talk about application like Instagram where user will upload the images and videos and there will be the user feed, I should also talk about the media delivery latency. Like, because whenever you open Instagram, you will see images and videos, because Instagram is famous for media content. So I need to make sure that the latency of the media delivery is also very low, because media would be stored in a separate place. So when I simply say latency smaller than 150 millisecond, that would more or less talk about the REST API calls, but I should separately mention about the media delivery latency, which means that how quickly the photos and videos were loaded after they were requested. So in system design, we generally use the CDN for static assets so that they can load very quickly without putting much of the pressure on the complete system. So all those things will come, but that should also come as a non-functional requirement. Another improvement area that I received on my answer was like, when we talk about the system like Instagram, I should specifically mention like giving priority to availability over consistency. You know the CAP theorem, right? Based on that, we have to set the priority. So here the priority is availability over the consistency. When I say consistency, it means like, for example, you get the user feed, you follow a person B, okay? So now user B has made a post. It is totally okay if you don't see that post at that moment. It can come after some time. So in Instagram, so I should mention I will prioritize availability over consistency, which means that users are okay watching slightly outdated content rather than no content. So availability is more priority as compared to consistency. So now based on the feedback, I have added these points here. You can see here I've mentioned availability is given more priority than the consistency. There would be low latency while feed loading. This is the additional part, like because one of the core functional requirement was related to the user feed, so there should be low latency while you show the user feed, and also there would be low latency in media rendering. Now after the non-functional requirements, let's move to the question number 2, which was what are the core entities of the system. When I say entity, it means related to the database. What are the important entities that would be required for the system, or you can say what are the core tables required in the system. So let me share what was the answer that I gave to this question. Okay, so this was my answers. So I mentioned like 5 core entities. The first one is users, which would contain information related to the user. The second one is post. So every post that you put would be part of this entity. The third one is follow, because in the functional requirement it was mentioned that a user should be able to follow another user. So this follow table would contain information like who follows whom. And number 4 and number 5 are related to like and comment related to the post. So whenever you put the post, other users are able to like or comment to your post, and that information would be part of these entities. So this was the answer that I gave to this question. Now let's see what was the feedback that I received. Okay, so in the feedback, first talking about what I did well, these things, users, post, follow, are the actual core entities of the system based on the functional requirements that were given to me. So these were correctly identified. Now after this, I received feedback from the interviewer that there can be some improvement made to my answer, which was related to the media. Now although we will store the images, videos in S3 storage and not in database, but there would be a separate entity, like we can name that as media entity, and that would contain other information like the URL for those assets. So media is another core entity that would be required for the system, and this I got to know from the feedback of the interviewer. So I missed this part. Talking about these two, like and comment, because these were not part of the functional requirements, these can be ignored, as in the question we are talking about the core entities only. So users, post, follow and media, these would be the core entities of the system. Now after this, let's move to the third question. The third question was related to what are the major API endpoints. So what all are the APIs that would be required for this system? Now let me share my answer with you. So this is the answer that I gave to the interviewer. So I mentioned these 5 APIs. The first one is related to following of the user. So API name is follow user. It is HTTPS, and it would have the input parameter as user ID because we need to tell whom to follow. The second one was related to the upload media, because images and videos will be stored in S3. We don't store the image or media directly to the database as blob. The better way is to store it into the S3 storage, and hence I'm providing an API where we can upload the media to S3 and it would return a download URL. The third API is related to creating a post. It would be also a HTTPS but a post API. So here is the request body that I shared. It would contain the user ID, the type, then the caption if any, then the media URLs and the timestamp. Apart from these three, I also mentioned couple of more APIs which were related to the update profile. This would also be HTTPS and post. It allows the user to update the profile. And the fifth one is the get user details, which would be useful to show the information on the profile section. So these were the 5 APIs that I gave as an answer. Now let's check what was the feedback that I received on my answer. Okay, so first talking about the good things about my answer, I identify the important things like follow user, upload media and create post, which would be essential and that were mentioned as the functional requirements. So I have created APIs for those. Another good part is like for create post, I have mentioned the request body which tells the fields which would be required, like the user ID is there, then the caption, media URLs and the timestamp is present. So it is a good practice when you can show some request or response with the API endpoint. It adds more clarity to the answer. So this was also good. Another good part to my answer was like I mentioned it specifically that the photos and videos would be uploaded to S3. They won't be uploaded directly to the database, and hence I shared a specific API for that part. So that is good. That shows to the interviewer that you have knowledge about this part. Okay, so after the good points, let's talk about the improvement areas that I received for my answer in the feedback. So in my answer, I missed a major point. I did not mention an API which would be used for the user feed. How would I fetch the data from another user and show to the user feed? So user feed was one of the functional requirements and I missed the API for that part. So that was one of the major missing. Another improvement area that I received as a feedback was the APIs like follow user and the create post. I haven't mentioned that what would be the response of these APIs. Like on the client side, what will user receive for these? It's better that I should also tell what would be the response. Like I mentioned the request body, I should also tell what would be the response of this API. So in generic, it's a good practice whenever you are talking about the API endpoints, include the request and the response for the same. So after these improvement areas, I also received minor suggestions which was related to say the naming conventions. The naming of the APIs could be done in a better way. Also, instead of writing it separately like it's a post API, what I can do is write something like this: post and then the endpoint name. So instead of writing follow users, I can rename it to follows. So this would be the API. It already tells this is a post API and this is the endpoint. Now the naming is also not verb based because I mentioned something like follow users, upload media, more on the verb based. It can be simply said like follows. So this is a better naming convention for API. Another suggestion that I received for my answer was like I added user ID in the request body, but generally fields like user ID would be part of the authentication headers. It should not be part of the request body. Keeping it in the headers is better for security because the authentication tokens like JWT are generally part of the headers. So this would be part of the security best practices in the API. From this feedback, I learned about the security related things of the API. So it's better to keep the things like user ID in the authentication header rather than keeping those in the request body. Another suggestion was like I mentioned update profile and get user details, but these are not as per the core functional requirements. So in the functional requirements we were mentioned like three important things related to user feed, related to creating post, and then following other users. There was nothing much mentioned related to the profile, so these are not actually required. There is no problem sharing extra information, but the only issue is that in interview you have limited time, so it's important that you focus on the core functional requirements kind of things. So this was an additional suggestion that I received on my answer. So you could see I received a lot of feedback on my API endpoints answer. It's actually good in a way that I can learn from it and improve so that I don't make such mistakes in the real interview. So after API, let's move to the next question, which is how will users create posts with photos or videos? So now we are talking about the media content in the post. Now let me share what was the answer that I gave for this question. Okay, this is the answer that I gave for this question. Basically, we have various components like client, there is load balancer for horizontal scaling, then there is gateway for authorization, for rate limiting, and for redirection of the request. Then after that, I'm using the microservice architecture. So I have the post service which will contain information related to the post, which will handle the logics related to post, and the post service is connected to the database and a cache. So I have also mentioned the entity that would be present here and all the important fields in that entity. Now an important part is that when we talk about the media, it is not directly stored in the database. We generally prefer to store the images and videos in the S3 storage. So the images and the videos will be stored on the S3, and rest of the metadata related to the post would be part of the post service and the database. Also you can see here that I have used CDN because CDN is used for the static assets. It can reduce a lot of latency. But actually in this question we were just talking about the post creation and not like how we will get the data on the user feeds, so it could have been ignored as well. So the major part was related to the S3 storage. So this was my answer. Now let's see what was the feedback that I received on my answer. In the feedback, initially I was told what I did well in my answer. So first thing was like I included components like S3 storage, and I also mentioned that the images videos will be stored in S3, so it's a good understanding and that's a good part. Apart from that, I have also mentioned the NoSQL database and cache. So all these components mentioned, these looks good. Also because in my answer I mentioned like load balancer, gateway, CDN, so it shows that I know the basic fundamentals of system design. So all of these are good. Now apart from that, I am using microservice architecture. You can see like there is a separate service, then there is a separate component for database, cache, S3, CDN. So it shows the good representation of the architecture. So all these things I did well. Now talking about the minor suggestions that I received on my answer, like here I mentioned the post entity and the fields that would be present in the post entity. One thing that I can include here is a status field which can tell the status of the post, because in real scenario the post will go through a lot of processing and things before it's visible to the user. So I need to maintain what is the current status of the post. For example, the media upload can fail, or it can remain in the draft stage or publish. So all those scenarios would be covered in the status field. So it's a good suggestion to include the status in the post entity. Apart from this, there are many other things, right? But that would be covered in the next set of questions, and this system design diagram would evolve according to that. So let's see the next set of questions. So the next question is, how will users follow other users? So now I need to modify my system design diagram for this follow flow. So let me share what was the answer that I gave for this question. So this is my updated answer. As you can see, some of the components are similar to the last diagram, but I have additionally added some of the things like the status field has been added in the post entity because that was the feedback I received in the last question. And apart from that, you can see I have added a follow service. So it is a separate microservice because it has its own set of responsibilities. So follow service will be connected to a database and a cache. I have also included the follow entity. So each entry would include a follower ID and a followee ID. and alongside with that I'll maintain a timestamp. So this will tell like who is following whom. So basically whenever a user follows another user, it will go to the follow service which will apply its logic and then save that information in the database. So this was my answer. Now let's see what was the feedback that I got on this answer. Firstly, talking about the good things in the feedback, I created a separate microservice to handle this flow, so it was good. Also, I connected it to the database and the cache, and I also mentioned like what would be the entity and the important fields that would be present in the entity. So this is good. Another good part is like I mentioned graph database for the follow service, because graph database is well suited for social network connections and relationships. So I use that and it looks good. Also because I use the cache, it would help to reduce the latency. So all these things are good. Now let's talk about the improvement areas that I got to know during my feedback. So the improvement area is like in the diagram, I just added a new component here and connected it with the database, but I should explain it more like how will the flow work. For example, in case of follow, I can tell like the API endpoints like post, follow, user ID will be hit. In similar way for unfollow, this API endpoint delete, follow, user ID will be hit. Apart from that, I should also tell like how the follow service will validate the request, what logic it will apply, how it will query the database to fetch the followers or the followees. Also apart from that, as I am using the graph database, if I could tell more information about it, like how using it will make the things more efficient, that would be good. Like similar is the case for the cache, because I mentioned that I'm using a cache here, so I should also tell like how it will help. So if I cover all those things by myself, interviewer doesn't need to ask specifically all these questions, because also it shows like I have a good understanding of my core concepts. Whatever I'm using, I know its fundamentals. Okay, so after this, let's see the next question, which was related to the user feed. Now user feed was one of the core functional requirements. So this question is like how I will show the user feed in the chronological order. So let me share my answer for the same. So this is my answer to the user feed. There are a lot of things here which are common to the last answer, like client, load balancer, gateway, CDN, S3, post service, follow service, cache and database. Now apart from that, a new component has been added. So user feed service is a new microservice which will handle this flow. So basically what's happening is like it is connected to the database, cache, and apart from that it would also need to connect to the post service and the follow service. So you can also see here like I have mentioned couple of things. Data already pushed for normal users post, whereas data is fetched for the famous followers. So what does this mean? Let me explain you in a very simple way. Say if we talk about the brute force would be whenever a user opens the Instagram, a microservice need to fetch like a list of people who this user follows, and once we have the list of the users whom this user follows, then there would be a microservice which would fetch the post of each of the user. So let's say there are 100 people whom this person follows, so one by one we need to fetch all the posts of these people, and that should be sorted in a descending order based on the creation time, so that you can see the latest post at the top and going down you can see more such posts. But you can clearly see in this complete flow there would be huge latency. It is quite slow because first you will fetch the list of people who you are following, and then for each of the person you are trying to get all the posts, so it will take a lot of time. But in the non-functional requirement we mentioned that low latency in terms of displaying the user feed. If I am following this way, then there would be a huge latency and customers would lose interest, because when they open the Instagram it would take a lot of time to just show the user feed. So this is not a great way. So how to do this? So basically what I'm going to do here is like this is user A, and user A follows another user B. So whenever user B creates a new post, what I'm going to do is like B is going to add that in the cache of A. So there is already pre-computed data for A. Similarly, A also follows C. So whenever C creates a new post, that information will be pushed to the cache of A. So this information is not only pushed to A, it will be pushed to all the people who follow C. So for example, in first case, all the people who follow B in their cache, this information will be pushed. Similarly, when C makes a post, all the people who follow C in their cache, the information related to new post will be pushed in their cache. Why we are doing that? So that whenever this user opens the user feed, the data is already pre-computed. The cache of A already has data of B and C. So basically you can see this is a push based approach. Whosoever A is following, whenever they are creating a post, that information will be pushed to A's cache. Not only A's cache, to all the people who are following B. So because A was also following B, so in that list A will come and that information will be pushed to A's cache. Now you can clearly see that the process of pushing this information to all the people who follow B or C would take time. So it would be done in asynchronous way. So we can use message queue for that. So this was a push based model, but there comes a problem. Say for example, when we talk about the famous people, like sports people like Messi or Ronaldo, or movie stars like Tom Cruise. So all these people have a lot of followers. Say a famous person has like 10 million followers. So using this push based approach, whenever a famous person creates a new post, what we are doing is like pushing it for 10 million people. So we are creating a lot of requests by our own. What it may do is like bombard our own system. So our own system can go down because what we are doing is like we are sending so many requests from ourselves. So this push based approach does not work for famous people. So for famous people, what I want to do is do a simple pull based approach. Like whenever A opens the Instagram, so for all the famous people whom A follows, we will pull that information. Like for each of these famous users, this information would be present in their cache, and we can fetch that information from their cache. So basically what I'm doing here is like for a person A, there can be two set of people. First is like people who are not famous, and other are the people who are famous. So what criteria will I use to differentiate that? I can keep any criteria, like any person who has like more than 10,000 followers, I will consider them as famous people. Or you can modify that to 100,000 as well. 100,000 followers, famous person. Less than that, I would consider it as a normal case. So in normal case, I will use this push based approach. So whenever that person will create a post, all the people who follow that person, this information will be pushed to their cache. But in case of famous people, that won't be done. So for A, I have two cases. For first case, the data would be already pre-computed and present in my cache. But for other case, I will simply use the pull based approach and fetch the information from their cache. Now I will have both the data. I will combine those and make sure that it is in the sorted order based on the creation time in descending order and display it on the user feed. So this was my answer. Now let's see what was the feedback that I received. Firstly, talking about the good part, like I created a separate microservice here, so that's a good part. Connected that with the database, cache and other important services, so that's all good. Another good part is the hybrid approach that I just mentioned, like the push based approach for the normal people and the pull based approach for the famous people. So it shows that I have good understanding of this concept. Now talking about the improvement areas, because it was specifically mentioned in the question that it should be in the chronological order, I could have explained it more, like because I have told here it's a database, I said like it would be sorted, but I could mention something like while querying I would do something like order by creation time descending. So this like 4 words explain like I know the fundamentals of this. Another feedback is like although I mentioned the complete flow, that could be described in the diagram in bit better way, like how will user feed service will fetch the followers for the particular user and differentiate those in between these two categories that I have mentioned, and then fetch the post of each. So that can be described in a better way in the diagram. So one thing that I missed in my answer was like the user feed is generally infinite scroll, right? You can keep on scrolling and checking the data, all the posts. So you can't get all that information in one go. Always such kind of things are the paginated response. So generally in a response we get like around 50 entries, and after that need to hit this API again with a cursor or offset parameter that needs to be mentioned in the API, and based on that the client will keep on getting next batch of data. So that should have been included in the answer. So another good feedback that I received was because I am querying from the post database, as I need the information in chronological order, so it would be good to index on the user ID and the creation time. That would help to reduce the overall latency. Otherwise there would be a full table scan that would have a lot of latency. So if you tell all such things during the interview, it really shows the interviewer that you have good fundamental knowledge about all these things, and that can set a really good impression. Okay, so after this let's move to the next question, which was related to the scaling of user feed. So a user might be following thousands of other users. So the question is like, how will I make sure that I can scale user feed and there would be a really low latency? So now let me share my answer for this question. So this is my updated answer. You can see I have added some more information to it so that in the diagram it could be clearly visible. Like I created two cases, like the normal case versus the famous case. So here you can see user feed is connected to the cache. It will fetch the followers. It will try to get that from cache itself, otherwise from the follow service. And based on that there can be two cases. So first case is post created by a person who has less than 1000 followers. So here I have taken the threshold as 1000. So less than 1000 normal case, more than 1000 famous people case. So in that case, whenever a user who comes in the normal case, in that will fetch all the followers of that person from the cache and the database. So you can see from the post service that is going to the follow service, and after that you can see the next step, push in the followers cache. So all the people who are following to the person who has just created the post and that person coming in the normal case, so the system is pushing that information in all the followers cache. So you can see that data would be already present as a pre-computed data in the cache. So whenever user A opens the Instagram, based on the followers, the normal case, the pre-computed data would be already present in the cache, and for the other case we'll fetch the post for the famous people from the post service, and that too will happen through the cache, because for a famous person we'll keep that information in the cache, because that will be fetched by a lot of people. So using cache would be a good option in there. And apart from this logic, I am using S3 as a separate component for storing the images and videos. So the media content is getting stored in S3. So this is a separate component. It is provided by generally AWS. So we can scale our servers, microservices, database independently. And apart from that, I am also using CDN. So when we talk about the case when user is trying to fetch the data, so all the images and videos, that is the static assets or the content, can be fetched directly from the CDN. It doesn't put any load on the servers or the database. All this information can be fetched directly from the CDN, which is geographically located. So in all the locations of the world, it is generally tried to keep it. And whenever a request comes, it is served by the nearest CDN available. So in this way, using the CDN, S3, cache, separate components which can be scaled independently, having load balancer, gateway, this scale can be managed. So this was my answer. Now let's see what was the feedback that I received. Firstly, talking about the good things about my answer, I used a hybrid approach, differentiated both the cases, the pre-computed data in one case and pulling the data in another case. So that would help in reducing the latency, and also following the pull based approach for the famous people, that would help because it won't bombard the system. So that's also good. Also using CDN, S3 and creating separate components, so which can be scaled easily. So these are all the good things in my answer. So now let's talk about some of the suggestions that I received in the feedback. First one was like, although I told like I would get the data pre-computed for normal case and fetch for the famous people, I also need to tell like how would I compute the data afterwards, because I have two sets of data, right? First is the pre-computed and other is the data of famous people. Now I need to merge these both of the data and show that in the user feed in the chronological order. So what is the algorithm, or what am I using to do this? Now I also need to make sure that this process of merging both of the results should be of low latency, because our end goal is that user should be able to see the user feed quickly. Another improvement area here is that for the case of pre-computed data, that is a normal case, when we are pushing the information in the cache of all the people who follow this person, I also need to add some information in the diagram related to the asynchronous handling. This is because, like, we can take an example. So like B is creating a post and 999 people are actually following B, right? So for all these 999 people, I need to push the information in the cache, so that would take time. So this should be handled in asynchronous way. So I could add a message queue here, like a separate component coming as Kafka or RabbitMQ, which would handle this asynchronous processing. Apart from that, I could also talk about some of the rate limiting algorithm, because there can be a time where there is huge load on the server, and at the same time, if I'm putting more load, like 999 new requests that needs to be handled by the system, so I should have some smart rate limiting algorithms. Say for example, currently only push for those people who are currently active, because there are many such accounts which remains inactive or they don't use it much. You don't need to push the data right away in their cache. This can be done later as well. And also the major part is that in the non-functional requirement we discussed, availability is more priority over the consistency. So eventual consistency is fine in Instagram user feed. If user is following another user and that user has created a new post, it's totally okay if it takes some time for A to see the post of B on the user feed. But availability is more important. User is okay to see bit of outdated data rather than no data. So all such smart algorithms can be implemented. Apart from that, like we talked in the last question, here also I could talk about the pagination. Like for each of the user as well, you don't need all the post information, just a few of the posts. Like, or firstly we try to take the few most recent posts, and then after that more information, because there is a paginated response that we need to provide to the client. Alright, so now let's talk about the last question that was part of this mock interview, which was related to the fast media delivery to the users globally. So as you know, media contains images and videos. How do I make sure that this media delivery is fast across the globe? So for this, I did not modify my diagram much. I just explained the use of CDN here. So basically what I'm using is a CDN, content delivery network. So CDN would be present all across the globe in various geography locations. So whenever a request comes for the static assets like the images and videos, it can be served by the nearest CDN available. So when a request is served by the CDN, it doesn't go to the servers or the database, so it is directly handled from there. So it would reduce the load on the servers and the database, and it would be really quick. So in that way, I'm making sure the media delivery is quite fast and it is across the globe, because CDN would be present in all the geographies in the world. So now let's see what was the feedback that I received on my answer. Firstly, talking about the good things that I did in my answer, yes, CDN is correct apart from the cache that is already used in the system. So CDN would be really helpful in the fast media delivery. So CDN is used for the static assets like images and videos, and that would help in reducing the overall latency. One thing that I missed in my answer was, like, across the globe there are various networks available. So some people might be using it in a mobile phone, whereas some people are checking it on the laptop. So the resolution may vary, the network availability, the bandwidth may vary. So I don't need to serve the same content to all the people. Like, instead of doing this, what I should do is, like, in between there should be a transcoding kind of service which creates separate version of the asset in different resolutions, and that should be present in CDN. So based on the resolution of the device and also based on the mobile network bandwidth available, the correct resource should be fetched and used. So that would really help, like setting up different resolutions of the same asset and serving the required resolution asset. So in this way I can serve the high resolution content to the people who are watching that at high resolutions like laptops and with the good network range, and I can use the compressed versions for the people who are currently using it on mobile and with low network bandwidth. Now apart from this, as I am talking about the CDN and this question is majorly about CDN, I should also talk about the caching strategies that I'm using in CDN. For example, TTL, that is time to live, the expiry, and similarly the cache invalidation approaches. So I should cover that in my answer. Also in generic, I should talk about or at least know about the fundamentals of CDN, because I'm using CDN here. I've mentioned that it's part of my diagram and this question revolves around CDN. So there is high probability that the interviewer might ask some of the questions related to CDN, like what is the approach here for adding the media content in CDN? Is it a pull based approach or a push based approach? What's the difference? Which one is better here? And similarly, how will I handle the failures in CDN to make sure there is reliability? What happens in case of a failover? So for that there are various strategies, the fundamental concepts related to CDN which I should know when I'm adding CDN as a component in my diagram and I'm talking about it, right? So be ready whenever you add something as a component that some of the questions may be asked related to it. Alright, so these were the questions that were asked to me in this mock interview. I found it really helpful because I got to know the feedback